Hi, my name is Neha Shetty and this is my reflection video number 1 for ENS 5010. So my disciplinary background is in biotechnology engineering with a minor specialization in environmental biotechnology. Today I will be speaking about the use of evidence and data analysis through my previous studies. I did my final year thesis project on batch studies for removal of methylene blue from aqueous solutions through adsorption onto Neurospora crassa biomass. Now getting into the project overview. In this project, we used dead biomass of Neurospora crassa, a kind of red bread form of the phylum Escomycota from the kingdom fungi, which was then used as an adsorbent for the removal of methylene blue dye, which is a highly consumed and toxic dye used in textile industries. The purpose of the study was to give an alternative solution to water treatment through biological processes for the betterment of the environment. For this experiment, we grew the fungal strains of Neurospora crassa in potato dextrose broth. And after the fungal strain had reached its maturity stage as shown in the figure, we kept it in the oven at 65 degrees Celsius overnight to kill it, which is then scraped off and turned into powder form. This powder form is then considered as biomass dosage for the experiments. Now let's get into the evidence-based experiment and data analysis. For the experiments, four major parameters were considered, it being effect of pH, effect of dead biomass dosage, effect of dye concentration, and effect of agitation speed. The ranges of each of these experiments were set based on previous studies done through literature review. Now speaking about the effect of pH was determined setting a range and adding biomass to the diluted methylene blue solution, and these readings were taken using a spectrophotometer. The pH giving the most amount of dye removal was considered. In this case, it was pH 12 giving a dye removal of 84.48%. Moving on to the dead biomass dosage. After setting a target pH, we find the amount of dosage to give us the most efficiency dye removal. Here, 0.35 grams gave us the most amount of efficiency. Similarly, with dye concentration, after setting pH 12 and 0.35 grams of biomass dosage, optimal dye concentration was found. Here it was found to be 100 ppm. If you notice, the dye removal percentage also increases by setting the optimal parameter measures. Final parameter being agitation speed, giving us the most dye removal of 95.78% at 150 rpm, which concludes this experiment by giving us the best outcome it at 12 pH with 0.35 grams of dosage and concentration of 100 ppm at 150 rpm. Moving on to the data analysis, this was found through design of experiment and analysis of variance. Design of experiments is carried out to eliminate a tedious trial and error method by using for composite central design. These are the range and denotions carried out for composite central design. Composite central design is a statistical experimental design for building a second order quadratic model without needing to use complete three-level factorial experiment. CCD was carried out to give us the most amount of dye removal and supporting our previous experiments through evidences. Once CCD is completed, we took the final parameters with the best efficiency and did ANOVA, which is also known as analysis of variance. ANOVA regression analysis is to give us the resultant regression equation through mathematical providing the maximum efficiency of 95.394 dye removal percentage. The importance of ANOVA is to learn more about the interactions and the parameters and to denote any possible errors that can occur through calculations and give us the optimal solution. This concludes my presentation and these are my references. Thank you.